Just a quick refresher video on how we calculate impedance if we're given resistance and reactance. Hopefully you'll remember all this. This was all part of your 2A course, but it doesn't hurt to go over it quickly again. So when we're given R and X values, which is what you'll get when you're calculating prospective fault current, you'll get given a resistance for a cable and a reactance for a cable. Well, then you actually have to find out the impedance, and it's just a matter of using Pythagoras. So some of you will remember that that's our triangle there. Well, and of course Z, so impedance in this case, is just the square root of R squared plus X squared. Not particularly difficult, but let's say we had a cable with resistance of 0.16 of an ohm. And the same cable had a reactance, that's actually RC, we'll call that RC for the cable, and XC is, say, it's 0.09 ohms. Alright, so easy enough to find out the impedance of that. If we put our triangle in. Now, of course, we're not interested at the moment in finding out the phase angle, which we could find out, but we're not going to worry too much at the moment. We're going to say this is 0.16 and this is 0.09. So the Z of that cable, so ZC is the square root of 0.16 squared plus 0.09 squared ZC. So we'll bang that in our calculator. So there it is. Now again, this is a great calculator for this. You just put in a square root sign. 0.16 squared plus 0.09 squared equals, and there it is. It's going to be bigger, because keep in mind we've found the hypotenuse, and you'll remember from your time at school when you learn about Mr. Pythagoras that the hypotenuse is the longest side. So there it is. It's 0.184 ohms. Not too difficult, hey?